Based on your observations and collaborations with the processor market, what trends do you think will become popular in the next decade?
I think that DPUs will follow a very well-known path that is called the Wheel of Reincarnation. There was a seminal paper that is called the Wheel of Reincarnation that was written by inventors of the first GPU about 50 years ago. So they realized that any accelerator architecture evolves in a very interesting but repetitive pattern where first one creates a simple accelerator to offload a tedious simple task to hardware. Then this accelerator gets more functions and eventually becomes programmable because you want to capture more workloads and make it more easily adoptable to different kind of applications. And then this accelerator becomes more flexible and powerful. And eventually, it turns out that this programmability and generality also you have to pay the tax of the overhead of this thing to be programmable. And as a result, the accelerator itself gets to a point where some of its own logic needs to be accelerated. So you have this babushka computer processor where you have a cost that has an accelerator that is programmable, that is its own has accelerator, that its own accelerator. So it's really kind of a nesting or fractal kind of structure. This is what they call the wheel of reincarnation. And it is absolutely true for all processors. And many of GPUs these days look like that, right? They already have their own co-processors that accelerate certain tasks like video encoding. So this is kind of a general idea, but making predictions is both easy and hard when you are in academia. It's hard because you have no clue what vendors are up to, and it's easy because you don't have to know that. So whatever I'm going to tell you now is more of a wishful thinking, and please take it with a grain of salt. I think what we will see more DPUs with more special purpose accelerators because that's the power of DPUs fundamentally. We will see more flexible pre-processing pipeline that will allow more control of what part of the network traffic gets processed on the DPU. And you would be able to splice network packets, putting some of them into the DPU, some of them into the host, and intermixing those. We will most likely see more work on trusted input output, which would leverage the fact that DPUs offer some of the infrastructural power that is not available on CPUs. On the other hand, we would want to offload some of the guest virtual machine workloads into the DPU. This is not yet happening. And whenever it will happen, those who would offload to the DPU would really want to make sure that the infrastructure provider does not have access to that data, which is exactly what trusted execution environments are for. I think the integration between DPUs and other accelerators in the computer system, like GPUs or any kind of other accelerators, will become more efficient. Today, it is pretty tedious to connect another accelerator to a DPU, and we have done that in the lab in the paper that we published 2 years ago. But it took us a while, and it does involve quite a bit of hacking around. Whereas I think that this would be a great opportunity for DPUs to really offload a lot of accelerator management in disaggregated data centers where accelerators can be sitting in some separate racks out of CPUs. So you really want to deploy some lightweight DPU there to manage those accelerators. Streamlining that path would be really important. I also expect the new intra-host interconnects such as CXL to offer substantial benefits and simplify application developers, just like in any accelerators. It would allow much tighter integration between the processing on the CPU and processing on the DPU so that you would really be able to push data back and forth without really worrying that once you're stuck on the CPU, you cannot really return your processing back to the DPU. I also think that DPUs themselves will become more powerful because you can scale them, potentially pushing a little bit more of a tightly integrating cores or some kind of other processors that, like GPUs, for example. NVIDIA, as I mentioned, announced already their future GPU integration with DPUs. I don't expect this GPU to be as powerful as any other discrete GPUs, but it will definitely add a bit to the vector processing, to the number crunching abilities in DPUs. I'm pretty sure that there will be many more players on that market that will want part of this pie because it seems that data centers are growing at a huge pace and this market is as well growing. Also, I would call it edge processing workloads would benefit from DPUs in one way or another. So all in all, it looks like DPUs are kind of getting into kind of a fast evolving stage with a lot of adoption and interest.